All right, let's just jump right in. I want you to imagine for a second that you're not just a farmer or a scientist, you're an investor. And the hot new startup you're looking at, it's not a tech company, it's a plant. Yeah, a plant. A super complex biological company. So today, we're going to do a full business analysis, break it all down to figure out how to manage its potential and, of course, get the best possible return on investment. We're talking about yield.
So, here it is, the central pitch, the billion-dollar question really. What if you could just command a plant to do what you want? I mean, literally tell it, hey, forget those extra leaves, pause growing the stock for a bit, and listen, I want you to pump every single last drop of energy you have directly into the grain. I know, it sounds like something out of a sci-fi movie, right? But this is the very real goal of agricultural science today.
So to even begin to understand how that's possible, we've got to look at the plant's internal economy. Think of it like a giant logistics network. On the left, you've got the factory. That's the leaf. It's powering a pump, a protein called SUT, that shoves sugar into a pipeline. And then, way over on the other end, there's a valve called sweet, and it releases that sugar to the city, the grain. And that's what the city uses for fuel to grow. It's really all about production and distribution.
Okay, so let's break down this whole business model a little more. Just like any successful company, a plant's profitability, its yield, comes down to one thing: how well it manages production and logistics. And this whole system is really built on two key players. So on one side, you've got the source. These are the leaves. Think of them as the factories. They're basically solar-powered sugar plants, just cranking out energy from sunlight all day long. And on the other side, you've got the sink, and that's the grain. This is our booming city, and it is the #1 consumer of all that energy. And it's simple, right? If the factory stops sending fuel, the city's growth just grinds to a halt.
And this brings us to a really crucial idea called sinkstrength. Now, it's not just about the city kind of sitting there and waiting for energy to arrive. No. Think of it more like market demand. A strong sink is an aggressive city. It's actively pulling fuel from the supply line, basically creating a vacuum that tells the factory, hey, we need more. The stronger that demand, the bigger the grain, and, you guessed it, the higher the final yield.
And of course, this demand is met by a pretty sophisticated supply chain. Here's how it works. First, the sugar gets made. Then, you've got these specialized proteins, SUTs, that act like little automated forklifts, loading all that sugar onto the transport highway. When it gets to its destination, other proteins called sweets are like automated unloading valves. And finally, an enzyme called C-wine, you can also call it invertase, does the final processing, converting that sugar into a form the grain can use right away. And obviously, if there's a breakdown anywhere in this delivery service, you're looking at a loss in profit.
So, who's actually running this whole operation? Well, that would be the management team. And in a plant, the management team is a group of powerful chemical messengers we call hormones. They're the ones sitting at the control panel making all the big decisions for the company. And believe me, this management team has some pretty big personalities. On the go side, you've got cytokinins. Think of them as the super optimistic CEO of growth, always pushing, always trying to expand the city's demand. But then on the stop side, you've got ABA. This is your cautious chief risk officer whose hand is always hovering over the emergency brake at the first sign of trouble. They're in this constant negotiation, and for things to grow well, you need that go signal from the CEO to be a lot louder than the stop signal from the risk officer.
So let's take a look at our CEO's key performance indicators, their KPIs. Cytokinins are basically master switches for growth. I mean, look at this. They boost everything, from the activity of that C-win processing enzyme to how well the SUT loading pumps work. They even have this amazing anti-aging effect on the leaf factories, keeping them productive for longer. So, in short, they physically force the grain to demand more energy.
But every business faces a downturn eventually. And for a plant, a market downturn is stress. We're talking about a drought or a major heat wave. And this isn't just some minor hiccup. It's a full-blown energy crisis that threatens the entire company.
And when that stress hits, the company's entire strategy just flips on a dime. The chief risk officer basically takes over and throws this huge master switch. The whole system goes from a green growth mode, which is run by a kinase called TOR, to a red survival mode run by its opposite, SNRK1. And what does that mean? Growth stops, grain development is aborted, the company goes into full-on austerity mode just to survive. And this panic-driven shift in energy, this is the #1 cause of yield loss, period.
Oh, but it gets even more dramatic.
When the plant is in survival mode, it actually activates an internal saboteur. It's an enzyme called CKX. And just look at this. It's literally shown as a pair of scissors. And its sole job, is to find and shred all those growth memos, the cytokinins we were just talking about. The plant is literally hardwired to limit its own potential. When it gets stressed, it starts destroying the very things that make it grow.
And this right here, this brings us to a complete game-changing insight. We can't solve this problem by just spraying on more growth hormones from the outside. That's like sending more memos to an office where someone has a paper shredder running at full blast. It's useless. To get a real breakthrough, a real change, we have to do one thing. We have to stop the scissors.
So the big question is, how do we do that? Well, this is where our investment opportunity really comes into play. What we need is a complete turnaround strategy, a way to override the plant's naturally conservative, self-limiting programming and basically hack the system for a much higher profit.
Now, a modern turnaround plan isn't just one simple fix. It's really this three-tiered strategy. First up, you have the agronomic level. Think of this as the first aid kit, using biostimulants like seaweed extracts to help reduce stress. Second, you have the chemical level. This is where we bring in targeted inhibitors to physically block those CKX scissors. And finally, the top tier, the genetic level. This is where we can use tools like CRISPR to permanently rewrite the plant's code for higher potential. It's a full-on engineering approach.
And if you look at the investor's chemical toolkit, there are a few different options. On one end of the spectrum, you have really powerful synthetic hormones like 6-PAP. And yeah, they're super effective, but they can be really tricky to get the dose right, and there's a risk of unintended side effects. On the other end, you've got things like seaweed extracts, which are milder, more complex biostimulants. They're generally safer, more stable, and just more practical for large-scale use. They give you a nice buffer against stress without the risks that come with a really aggressive hormone treatment.
But here's the thing. This creates a kind of paradox. If you just systemically boost growth hormones everywhere, sure, you get bigger grain, but you often end up with weaker roots, and that makes the whole plant vulnerable to drought. So the ultimate solution, the real holy grail, is genetic engineering. With something like CRISPR, we can perform molecular surgery. We can go in and turn off those CKX scissors just in the shoots to get that bigger grain, while at the same time letting the roots grow massive and strong. It's the best of both worlds.
You know, the chemical tools themselves have evolved like crazy. We've gone from the really blunt instruments they had back in the 1980s, which often had all kinds of side effects, to the incredibly selective inhibitors we have today. A modern molecule, like NCD, acts like a super precise shield. It physically blocks the active site on that CKX enzyme. So it's not adding any hormones, it's just protecting the plant's own natural growth potential from its own self-sabotage.
Okay, look, this all sounds great in theory. I get it. But for any investor, there's really only one thing that matters in the end: the return on investment. So let's look at the numbers.
What we're looking at here are the results from actual commercial field trials. And what's amazing is that it doesn't matter what the brand is or the specific formula, whether it's natural or synthetic, the effect is consistent across the board. By artificially strengthening that sink demand, these products deliver real, measurable increases in yield. So what's the bottom line? We're talking about a field-proven yield increase of anywhere from 8 to 25%. That is a significant return, and it's tied directly to better management of the plant's internal economy.
And listen, these aren't just empty numbers on a chart. This translates into real, concrete outcomes. We're seeing things like an 8.8% yield increase, even under severe heat stress. We're seeing enhanced overall resilience and a significant boost in the total biomass for both the shoots and the roots. In other words, this technology protects your investment even when the market, the weather, gets really tough.
So, let's circle all the way back to our original pitch. What we're talking about here isn't just farming anymore. This is bioeconomic engineering. It's about actively managing a plant's internal systems to get maximum profit. The technology's already here, the returns are proven, so really, the only question left to ask is, are you ready to invest?